Voice of Ash.
Who doesn't like the Pi? Especially Raspberry Pi. Okay, I'm not talking about the food here. I'm talking about a tiny computer. Hi, my name is Ash, and in this two-parts video, I'll take you on a journey to make an arcade game of whack-a-mole using Raspberry Pi. The first part is knowing the board, loading the operating system, working with various hardware components, etc. at a very high level. And the second part is about the game itself. So if you're already familiar with the board, you can skip over this part and go straight to part 2. If not, stick around and leverage from my journey, which started not too long ago. I'll see you shortly. So this is Raspberry Pi, a tiny but very powerful computer. It is very popular among the hobbyists wanting to build robotics or IoT projects. This inexpensive board costs $35. But lately, due to the chip shortages, the prices have jumped up to $75 on Amazon. But don't worry about it. I expect the prices to come down very near future because the supply is slowly catching up with the demand. Now, this particular Raspberry Pi is Raspberry Pi 3 model B+. The latest model, I believe, is Raspberry Pi 4. 3B+ has been around for a while, but has proved itself to be a very powerful board. Now, let us try to answer some very basic questions before we get started. So as soon as I got this board, I'm like, okay, it's a small computer, but how do I talk to it? So this board comes with the HDMI port where I can plug in a monitor. It has 4 USB ports. It even has an Ethernet port. But anyway, to get the computer started, we need to be able to see what the computer is saying or telling us, and we should be able to input the command. So I can hook a mouse and a keyboard, USB keyboard, in here, and I can plug in a HDMI monitor, and I can interact with the computer to get started. So last question is, how do we load operating system on this computer? And that is done through this storage device, a micro SD card. We will basically burn the operating system image on this card, and this will be a bootable image. And once that is done, it'll be obviously be done on a different computer. We will insert this card here, and once I power up the Pi, operating system will load up from this storage device. I'm using a 16 GB SD card, which is good enough. You can use more. I think even less, 4 GB should be fine as well. So I'm here on raspberrypi.com. I am clicking on software, and it says install Raspberry Pi using Raspberry Pi Imager. I'm using a Windows operating system, so I'm going to choose download for Windows. You can choose other options depending upon what machine you're using to image the SD card, micro SD card. Clicking on download for Windows, and it's going to copy this imager175.exe to my downloads folder, save. I have installed the Raspberry Pi Imager, and I'm ready to burn the operating system onto the SD card, which is already connected to my computer. So first thing is, I'm going to choose the operating system. As you can see, there are lots of choices. By default, it picks the 32-bit one, or recommended, not default. But since my board is 64-bit, I'm going to choose Raspberry Pi OS Other. And let's say, so in 64-bit, I have 2 choices. One is a light version, another one is not so light version, I guess. So I am going to use a not so light version. And now my next choice is choose the storage. As you can see, I have 3 different removable drives, but of course I'm ready to burn into my 16 GB SD card. I pick that and I click on write. All existing data will be erased. Yeah, go for it. And it's preparing to write. This prompt comes up from Microsoft Windows. Get rid of it. It's not needed. Cancel. Whatever. And as you can see, the writing process has started, and I will meet you after it is done. So we have finished writing to the SD card, and as the message says, you can now remove the SD card from the reader. The write process takes about 2 to 3 minutes, so be patient because it first writes and then verifies the content. So I will click on continue, remove the card, and we will ready to use this operating system on a Raspberry Pi. And I'll see you in a bit. Okay guys, so here I have wired up everything, is ready to go. So that's my Raspberry Pi, one mouse, one keyboard connected to USB ports, and this is that little monitor. It's about 6 or 7 inches screen, and has got a little HDMI cable which is going into the HDMI output of the Raspberry Pi. Raspberry Pi is connected to the power. I haven't turned it on yet, and monitor is getting its power through this battery bank. Okay, so let's power on this beauty. First thing I need to do is turn on the monitor, make sure that the monitor is getting its juice, and let's turn it on. And okay, so as you can see, red LED is on and something is happening on, and there it is. Any day now. Okay, so the operating system has booted up, and it's probably going to prompt me with a few setup things like what you want to call your computer, connecting to Wi-Fi, etc. So from now on, I will just try to record the screen images being shown on this monitor, and I will be right back. So clicked on next, and now it's asking me to pick the country. Create a user, choose a password, and it's something related to screen. I just skipped over it. Now I'm selecting a Wi-Fi network, my home Wi-Fi, putting the password in, and next prompt is to update the software. This may take some time. Finally, setup is complete. Click on restart. And after restarting, this is what we get. Click on the Raspberry icon on top, choose Preferences, and choose Raspberry Pi Configuration. And you will get this screen. We want to turn on a few things here. We want to turn on SSH, VNC, SPI, I2C, serial port, and serial console. The most important one is SSH. This will allow you to do a command line terminal session from a remote machine, which is what I will be using from now on without using an explicit keyboard and monitor connected to the Raspberry Pi. So now that Wi-Fi is all set up, I'm ready to get into Raspberry Pi from a remote computer. I'm pinging it, ping Raspberry Pi 1, that's the name of the computer I gave, and it's responding to my pings. And now I'm going to SSH into it. And -L, meaning I'm going to use Pi as the user ID, and I type in my password, and I'm in from a remote computer. Let's do some directories here. And there you are. Hostname is Raspberry Pi 1. Okay, so how do we develop software for Raspberry Pi? The languages used are C and Python. I'm not sure, probably there are other languages too, but these are the preferred languages. I prefer Python over C because I don't know C. So my preferred way of doing development is that I do it on my Ubuntu desktop machine, and I commit the code to my GitHub repo, and I pull it down from Raspberry Pi. So for example, I am going to do make a change to a file which I have already put some code in. It's for a blinking LED tester. So this blinking time right now is 0.25, and I would change it to 0.5 seconds. So Control X, save the buffer. and do a git add star git commit -m change blinking time and git push. And now I will remove desktop into the Raspberry Pi and I will do a git pull from there. SSH raspberry pi 1 dot local -l a Kumar, that's my user ID, and I will enter my secret password. And now I am doing a remote session on my Raspberry Pi computer. So let me go to the folder where all these files are copied. And you can see that I work with Windows also, dir command. PyLab. Okay, so let's do a git pull so that we have the latest commit which I just made for the timing of this LED. And I have this change. Let's make sure that we have the latest file. So let's do a nano blink led.py. And we have this change because the very last line it was 0.25 and I changed it to 0.5 seconds. Okay, so all there is left to do is to run this program. That command would be python blink_led.py. And when I hit enter, the LED will start blinking. So I'm going to turn the camera on my Raspberry Pi computer so that we can watch this code being executed and the LED blinking at the same time. I'll be right back. Okay, so I'm ready to execute this program on the board. As you know that I'm remote shelled into the board. And let's talk about this setup here. There's a little LED connected with a 220 ohms resistor, and it's connected to pin number 17, and this white wire is basically ground. So let's hit enter, and in a second, and as you can see, LED is blinking, nothing to it. Wow. If you made it this far, I take it that you liked the video. Your journey is just starting, and it'll be a good one, I promise you. It'll be taxing to your wallet a little bit. You'll be buying this, and this, and this. But you know what? In the end, it will be worth it. So to graduate in this Raspberry Pi 101 tutorial, I suggest that you work with simple hardware devices like LEDs, relays, switches, etc. using the code at Raspberry Pi Foundation website, or you can find some code samples under my GitHub repo. I've included the links below. And we will meet again in part 2 of this video to make the game of Whack-A-Mole. I'll see you soon.